Guys, let's take some time and look at these questions about one proportion z-tests. So, question number 34. This is a scenario where the conditions are not met. So there's a randomness and independence condition and a normality condition each time. So let's check them. So in this situation, we did have randomness. We took a simple random sample of 200 alumni. So in this situation, independence is met. 10 times 200 is 2,000, and that's certainly less than or equal to the 15,000, which is the number of living alumni they claim. So the problem is the normality condition. The success count is 200 times 0.99. Remember, when you check the normality condition, what you need to do is use the null hypothesis value. So 200 times 0.99, that's 198. That's certainly greater than or equal to 10. But the problem is the failure count. 200 times 0.01 is only 2. That's less than 10. So our expected success and failure counts both need to exceed 10 or more for us to believe that the sample proportion follows an approximately normal distribution. So in number 34, it's the normality condition that has failed. Number 39, so a couple of things here. You can see the parameter is described as the proportion of students satisfied with the parking situation. You should always describe it in context. So you can see the null hypothesis value is specified with an equation. If nothing has changed, then the proportion that are satisfied with parking is still 0.37. So we're looking, though, for evidence of an improvement. So the alternative hypothesis needs to be a greater than alternative. We're looking for evidence that the proportion has exceeded 0.37 in the population. So randomness is met. We have a simple random sample of 200 students. Independence is met. 10 times 200 is 2,000, and that's less than or equal to 2,500 students at the school. Normality is met. Again, notice we are using the 0.37 from the null hypothesis. So 200 times 0.37 would be 74. 200 times 0.63 would be 126, and both of those are greater than or equal to 10, so the normality condition is met. When you are doing a test, or for that matter, if you're also building a confidence interval, one of the things we want you to be in the habit of is naming the procedure that you are using. So in this case, this test is called a one proportion z-test. So we're using z-scores, so that's why it's a z-test. And in these contexts, we are using single proportions. That's why it's called a one proportion z-test. So the test statistic is the z-score. So in order to calculate that z-score, you have to look at the sample proportion. 83 out of 200 creates a sample proportion of 0.15. So you can see that I've used it in the z-score. I subtracted the null hypothesis value of 0.37, but notice I am using that null hypothesis value to calculate that standard deviation in the denominator because we're assuming the null hypothesis is true. The p-value that we are going to report assumes the null hypothesis is true, so we have to use that 0.37 when we calculate our z-score. So we are looking then for z-scores that are greater than 1.32. Notice the direction. The greater than comes from the alternative hypothesis. So if you use the normal CDF command, 1.32 would be your lower boundary, 10 would be your upper boundary, and you can get your 0.093. So writing the conclusion is probably the most important part of a significance test. We know that your AP exam this year is going to de-emphasize calculations and is going to emphasize explanations. So being able to write this conclusion is important. So there are three things that you should do. Number one, you should make an explicit comparison to alpha, to the level of significance. So here the p-value is 0.093. You should write that that is greater than 0.05. Or whatever level of significance was given in the problem. If one is not given in the problem, you should use 0.05. So once you've made that comparison, the next thing you need to say is whether you've rejected or you have not rejected the null hypothesis. So in this case, the result is not unlikely. So the p-value is larger than alpha. This is not an unlikely result. So we do not reject the null hypothesis. You could write we fail to reject the null hypothesis. That would be fine. So now notice all of the nots go together. The last thing you need to do then is write about your conclusion, and that conclusion needs to be written using the alternative hypothesis. So the alternative hypothesis was looking for evidence that the proportion of students that were satisfied or approved with parking is greater than 0.37. Well, we did not reject the null hypothesis. So notice I said that we do not have evidence. Use the word evidence. We do not have evidence. And then everything else is just re-describing the question. We don't have evidence of what? Well, that the percentage of students that approve of parking is greater than 0.37. So there are three things. Compare the p-value to alpha, number one. Number two, either reject or do not reject the null hypothesis. Number three, then write about whether you do or you do not have evidence for the alternative hypothesis. Write it in words. Now, look, on this screen here, you can see the z-score, and I explained how you would find the p-value, but I really don't want you to show the work. At this point, I would rather that you be using your calculator. So let's make sure that you can see how to do this on your calculator. So if you go to Stat and over to Tests and scroll down to one proportion z-test, which is abbreviated on the calculator, one prop z-test. So the null hypothesis value that we specified in our null hypothesis was 0.37. So you can see here on the screen we had 83 successes out of 200. So the x is 83. The n is 200. This was a greater than alternative because we were looking for evidence that how students feel about parking has improved. So if we highlight calculate and press enter, notice there's the z-score of 1.32. Here's the p-value of 0.093, 0.094-ish. There we go. So the 0.145, that right there is the sample proportion. That is not the test statistic. That's just p-hat. That's just the sample proportion. So really everything you need in order to complete a significance test, you really can do on the calculator. We want you to think about the writing. The writing of the conclusion is the most important thing here. So next question then. Number 46. So here we're looking at the proportion of students that believe it's important to be well off financially. So the null hypothesis value, remember the null hypothesis value is always written with an equal sign. That's always an equation. So if nothing is different in this population, we would expect the null hypothesis value to be 0.73. We are looking though for evidence of a difference. We're looking for evidence that this population, for whatever reason, is different from 0.73. So the alternative hypothesis here is specified as a not equal to alternative because the question does not suggest whether we should be looking for evidence that the population's proportion is greater or less than 0.37. We're just looking for evidence of a difference. Randomness. The question states that we took a random sample of 200 students. For independence, 10 times 200 is 2,000. And notice how I described this. The question stated that this was being done at a state university, and I don't know the number of first-year students at a state university, so I should describe then what that population size is. So, and if it's a state universities tend to be pretty large. So 2,000, it's reasonable to believe that that's less than or equal to the number of first-year students at a state university. So notice, for normality, you need to be using the null hypothesis value of 0.73, the p-value that eventually we will calculate and apply. That p-value is a conditional probability. It assumes the null hypothesis is true. So our work needs to be using that null hypothesis value. So 200 times the 0.73 is 146. 200 times 1 minus 0.73, that's 54. Both of those are greater than or equal to 10, so the normality condition is easily met. The test name, this is a one proportion z-test. So the test statistic, be careful, this is not the test statistic. 132 out of 200, this is the sample proportion. This is the statistics, the value that we got from the sample, and that's described with the sample statistic, that's a p hat. So that's 132 out of 200, that's 0.66. That is not the test statistic, that is the sample statistic. The test statistic is the z-score. So the z-score that you get using the calculator here is negative 2.23. The p-value that you get using the calculator is 0.026. So before I write the conclusion, let's stop and make sure you know how to do that on the calculator. So same thing, one proportion z-test. So this time the null hypothesis value is 0.73, so that's the first thing that I need to enter. The number of successes was 132. So in this context, I had the same sample size of 200, so I'll leave n at 200. Now, I do have to change here the specification of the alternative hypothesis. The alternative hypothesis is a not equal to alternative, so I need to include that. Then I can highlight calculate and press enter. So notice there's the z-score of negative 2.23. Here is the p-value. It's 0.026. There's the same p-value that I had in the PowerPoint. This right here is not the test statistic. This is the sample statistic. Samples are described with statistics. So this is the p hat, if you will. There's the 0.66. That's what was used in order to calculate the z-score. And then we can write our conclusion. So remember, for the conclusion, we should compare the p-value to our level of significance. Again, we'll use the most common level of significance. That's 5%. Then we either do or don't reject the null hypothesis, and then we write our conclusion where we either do or don't have evidence of the alternative. So this time the p-value is less than the 5% level of significance. So there's our comparison. So because this is an unlikely result, we do reject the null hypothesis. So now we've done the second part. So since we have rejected the null hypothesis, we do have evidence of the alternative. So make sure you use the word evidence, and then you can use the words in the statement of the problem, in the statement of the question, to write this last sentence. So notice I said there is evidence to suggest, and then really the rest of this came from the statement of the question. To suggest what? Well, that the proportion of first-year students at this university that believe being financially well off is important is different from 0.73. It is okay to use the words in the statement of the question to help you write your conclusion. That's actually a smart strategy. So because this question is a two-sided significance test, we could also do this same question by using a confidence interval. So let's build that confidence interval using the one proportion z interval command on the graphing calculator. So stat, I'll go to tests. So you have to scroll down, and do not use this option here that says z interval. You need to use the option that says one proportion z interval. We are working with a single proportion. There it is, one prop z int. And notice we just did the significance test, so the calculator transfers over our number of successes and our number of trials to the one proportion z interval command. Because we did our significance test at the 5% level, our C level, that stands for the confidence level, that needs to be specified as 95%. So the level of confidence and the level of significance, those have to add up to 100% in order for the confidence interval to match the result of the two-sided test, the not equal to alternative test that we just did. So we'll highlight calculate. So there's the confidence interval, 0.594, 0.726. So those are the ones that we need to use. Those are the boundaries we need to use when we write our statement for interpreting our confidence interval in part A. So we are 95% confident, and what we're trying to capture is the true proportion of first-year students at this state university that believe being financially well-off is important. We believe those boundaries are between 0.594 and 0.726. Those are exactly the ones that we got on the calculator, 0.594, 0.726. So that's the confidence interval. So part B, what does this tell you about the true national value of 0.73? Well, notice if you look at the boundaries, 0.73 is not captured by this confidence interval. Remember, the goal of a confidence interval is to try to capture the true population proportion. Well, 0.73 is not a possibility for the true national value because it is not within that confidence interval. So the most important thing you can tell me is that 0.73 is not in the interval. So think about it. That's why we rejected the null hypothesis of 0.73 in question number 46. So saying that 0.73 is not in the interval, that is another way to say that we have evidence that the proportion of first-year students at this state university that believe being financially well-off is important, we have evidence that it's different from 0.73. Why? Well, because this interval is supposed to try to capture that true population proportion. Well, we have evidence that the true population proportion can't be 0.73 because 0.73 is not in the confidence interval. So that corresponds to rejecting the 0.73 in the previous significance test. Why did we reject the 0.73? Because we believe in that significance test from the low p-value. We believe we have evidence of the alternative. We have evidence that the true proportion is different from 0.73.